So in this question, we've been told that a particle p is moving with constant acceleration 3I minus j. We're then told that at time t, the velocity of p is v. This sentence is a bit redundant because we already know that v is going to be a future velocity or a current velocity after some time has elapsed. So don't get confused by this sentence. The next one does tell us that when t equals 0, v equals negative 2I plus 3j. This is another one where you need to be careful. When t equals 0, that's the beginning of the journey. And we know the velocity at the beginning of the journey, we usually call that u. So as much as this has told us v, we know that this is a vector for u, the initial velocity. Okay, so just some things to be confident on as we're reading through the question in the first instance. So part A asks us to find the value of t when p is travelling parallel to the vector I. So with the information we have so far, let's go ahead and collect some SUVAT variables. So we don't know the displacement at the moment, but like I said, we do know the initial velocity. That's the negative 2, 3. The acceleration is 3, negative 1, and we don't know much else. Part A of the question does want us to find the value of t when the particle is travelling parallel to the vector I. Well, we know that the direction that a vector is travelling, that is indicated by its final velocity or current velocity. That's indicated by the variable v. So let's go ahead and find an expression for the variable v. So that's what we're looking for, and time we'll refer to as t. These are all linked by v equals u plus at. Let's substitute in the vectors that we know. So negative 2, 3 plus 3 minus 1t. We can write this all as one big resultant vector, and this is what we get. V equals negative 2 plus 3t for the I component, and 3 minus t for the j component. We're told we're trying to find the time when the particle is moving parallel to the vector. So that means its velocity must be in a form showing it's parallel to I. Well, that means its velocity is in this form, where v equals k0. Where there is some horizontal movement, that's what the I component tells us, but there's no j component, there is no vertical movement. That's why we have k0. We have some value for I, but we have a definite 0 for j. This is the form where we know it's moving parallel to I. This means that the vertical j component, we should be able to set it equal to 0 and solve for t. So 3 minus t equals 0. Instantly, we know that t itself equals 3. So this is the value of t, the time, when the particle was travelling parallel to the vector I, when the particle had a 0 component for its vertical movement, had a 0 component for j. Part B of the question says we must determine the speed of p when t equals 5. Okay, there's a little bit of nuance here. You have to be careful. We've been asked to find the speed. When working with SUVAT, you know that we're finding the velocity. The speed is going to be the modulus of that velocity, particularly important when we're working with vectors. So we're going to find the modulus of the velocity when t equals 5. Let's find the velocity. We're just going to substitute our 5 into the expression we found earlier. That gives us a velocity of 13, negative 2. And to find its magnitude, to find the modulus, we're going to apply Pythagoras. 13 squared plus 2 squared. That gives us 13.15 meters per second. The speed of that particle when time equaled 5, 13.15 meters per second. Part C, we're asked to find in degrees the angle between the direction of motion of p when t equals 5 and the vector j. So we're actually being asked to find the angle between the velocity vector we just now found in part B and the vertical unit vector. I'm going to get a quick diagram just to make sure all of this comes out correct. So the vector we're working with is 13 to the right and down by 2. So it's this diagonal line. I'm going to label this, and the internal angle here is alpha. and here's the vector j, the unit vector j. We need to find the angle in between the two of them. Looking at this, if I can find alpha, I need to do 90 plus alpha, and that gives me the angle in between these two. So let's start with finding alpha. This is a right angle triangle. I'm working with sides and angles, so straight away we know it's trigonometry. I'm working with the opposite side and the adjacent side, so that's going to be tan. Alpha is going to be the inverse tan of 2/13. That gets us an angle of 8.746 degrees. Adding on the 90, once again we should do this in our heads, we'll get 98.746 degrees, or rounding to 98.7 degrees. So in this case the diagram helped to make sure we were focusing in on the correct angle and we knew what to add or subtract away from. Being really careful to produce the unit vector at the point that the original vector started from.